Okay, so this is the second problem of a relationship between delta G naught and the K. I think the focus of this problem is how to understand the statement. Okay? The reaction is given, and to me, this is the most important part of the knowledge is that this problem is trying to want you to know. Okay, so they say this compound chlorine nitrogen oxide that they are decomposed into those chlorine gas and NO gas, and the extent of reaction is 5%. So that's the way it is given. And then they ask you what is approximate value for delta G 298. Okay? And when say 298 means temperature is 298. That's one I can understand that. And the equation that we know is this equation, delta G naught is minus RT ln K. So I guess delta G value can be calculated based on the if we can calculate the K values here. Okay? Because this is about, in a way, equilibrium concentration. So this is being given this way. And just for refresh your memory, this is just an extra one that I have written down. This is a Lewis structure of this, and they go back and forth with chlorine gas and NO gas. And NO has these Lewis structures. So oxygen is 6, nitrogen is 5. You remember all this routine that you went through? This is going to be very useful, and it's going to be very important to know. Okay? So these are all the Lewis structures, and as you can see, okay, I think I find out the way that it's written. That's the octet rule. This one do not satisfy the octet rule. This is a very, very unstable gas. Obviously, it's going to be it's not good. This is going back to refresh your memory. If you have an NO minus compound, and this is actually pretty good. The way that it is written is, here you go. So you have one extra nitrogen, so everything is on octet rule satisfaction. The overall charges is negative. The former charges here is right on to the nitrogen because they have an extra electron onto the nitrogen, so that's the way that it's written. I guess stoichiometry-wise, this is the way that it is written. So that's a little recap on your Lewis structure before, and then I am going to do the following. So let's do this. So I means initial, C means change, and E means equilibrium. Okay. So initially, all I have is this statement, right? So keep that in mind. But I'm just going to do the things in a much more simple way than I'm going to assign the meaning. So what I'm going to do is, in the beginning, I'm just going to pick the usual easy concentration. Initial concentration of this compound as a reactant is 1. And then there's nothing and nothing. This is my initial condition. Okay? So initial. And what's my change is I'm going to say I'm going to lose 2x. X is coming and 2x. That's easier for me than, I guess, 1x, half x, x, right? You can do that, but this is my choice because it's easier for me to say. And then it's about the equilibrium constant. So if you do that, what is your equilibrium concentration? 1 minus 2x. X, 2x. So those are the concentration of 3 of those compounds. And then let's go back to this statement here. So decomposition is about 5%, means this is amount of decomposition. Okay, I think that's good. So therefore, minus 2x is 0.05. That's a 5%. So therefore, I think the x is, well, we can say that 2x is, the magnitude is 0.05, so 0.025. So that's my concentration change given as an x, and I have all the information. So then I'm in business now because a K is ClNO to the square. And the product is chlorine NO square. Okay. So this is a definition, and then what do I know? Let me put a, so this, because this is a 0.5, so this whole value is 0.95. This one is 0.025. This one is 0.05. Okay. So that's your equilibrium concentration. So I'm going to write 0.95 square. 0.25 square. Okay. So I got that, right? So I plug in those numbers. And what do I got? The K value that I have is 6.9 10 to the minus 5. So then they want to calculate delta G naught at 298 Kelvin, which is minus RT ln K, once again 8.314 298 natural log 6.9 minus 5. And this is 23.700. Say 3.7 kilojoule. So that's the answer for what was the question is, what is a delta G value for this reaction, right? So that's the delta G value, and I cannot and I should not write per mole. Okay, it is. I mean, somebody will keep that in your mental mind that this is a per reaction. And in my version is per reaction as written as it is on the blackboard on this day, right? So that as the reaction is written, so this is just a kilojoule is the